So what do you know? It's time to work on dynamic disks. Yeah, so let's get started, huh? Well, the dynamic disk is a physical disk that manages its volumes by using the LDM database. Wait, what? What's an LDM database? It's just an acronym for Logical Disk Manager. And it's actually just a megabyte, and it's hidden at the very end of the dynamic disk. The 1 megabyte database records all the information of the volumes on a single disk. And it also holds some related information on each dynamic disk, such as drive letter, volume label, the beginning sector of the volume, volume size, the file system of the volume, the current dynamic disk, and so on and so forth. Each dynamic disk will hold the mentioned information if there are several dynamic disks on your computer. So it means that all dynamic disks are going to be interrelated. The relevance of each dynamic disk allows you to see a missing disk shown in Windows Disk Management when you remove a dynamic disk from your system. So all this will be saved in the LDM database, which makes the LDM database, well, right up there in importance, like your partition table of a basic disk. So here, let me show you a beautiful diagram. Here, the blue area, this is the beginning of the dynamic disk. This is the MBR, which saves the information of the partition table on the disk. You knew that. So this partition table is not actually quite the same as the ones of a basic disk, though. Its main function is to make Windows and other disk managers know the disk is a dynamic disk, not just an empty one. So the blue area here, the end of the dynamic disk, is the LDM database. Now, Microsoft Windows offers a couple of types of disk storage. It's basic and it's dynamic, okay? Two different types. The basic disks are the disks that are most frequently used on Windows computers. A basic disk contains partitions, which we call primary partitions, and logical drives. So if you want to know more about the basic difference between basic disks and dynamic disks, have a look at this. Basic storage uses normal partition tables supported by MS-DOS, Microsoft Windows 95, Microsoft Windows 98, Microsoft Windows Millennium Edition. That's the ME or ME, right? Anyway, Microsoft Windows NT, Windows 2000, Windows Server 2003, as well as Windows XP. A disk that's been initialized for basic storage is then called a basic disk. So basic disk contains basic volumes, such as primary partitions, extended partitions, and logical drives. Additionally, though, basic volumes include multi-disk volumes that are created by using Windows NT 4.0 or earlier editions, such as volume sets, stripe sets, mirror sets, and stripe sets with parity. Windows XP does not support these multi-disk basic volumes. Now, any volume sets, stripe sets, mirror sets, or stripe sets with parity must be backed up and deleted or converted to dynamic disks before you go and install Windows XP Professional. So, dynamic storage. This is what's supported in Windows XP Professional, Windows 2000, Windows Server 2003. It's a disk that's been initialized for dynamic storage, right? So we call it a dynamic disk. The dynamic disk contains dynamic volumes, such as simple volumes, spanned volumes, striped volumes, mirrored volumes, and RAID 5 volumes. With dynamic storage, you can perform disk and volume management without restarting the Windows machine. Dynamic disks are not supported on portable computers or on Windows XP Home Edition-based computers. You cannot create mirrored volumes or RAID 5 volumes on the Windows XP Home Edition, Windows XP Professional, or Windows XP 64-bit edition-based computers. However, you can use a Windows XP Professional-based computer to create a mirrored or RAID 5 volume on remote computers that are running Windows 2000 Server, Windows 2000 Advanced Server, or Windows 2000 Data Center Server, or the standard, enterprise, and the data center versions of Windows Server 2003, or the starter, basic, home premium, business, enterprise, and ultimate versions of Windows Vista. Storage types are going to be separated from the file system type. So basic or dynamic disk can contain any combination of FAT16, FAT32, or NTFS partitions or volumes. A disk system can contain any combination of storage types. However, all volumes on the same disk must use the same storage type. You with me so far? Cool. Let's move on. So we've got a volume, right? This is a storage unit. It's made from free space on one or more disks. It can be formatted with a file system and assigned a drive later. Volumes on dynamic disks have the following types: simple, spanned, mirrored, striped, or RAID 5. So a simple volume uses free space from a single disk. It can be a single region on a disk, or it could consist of multiple concatenated regions. A simple volume can be extended within the same disk or onto additional disks. If a simple volume is extended across multiple disks, that's when it becomes a spanned volume. Indeed, a spanned volume is created from free disk space that is linked together from multiple disks. You can extend a spanned volume onto a maximum of 32 disks, however, and a spanned volume cannot be mirrored, and it's not fault tolerant. A striped volume is a volume whose data is interleaved across two or more physical disks. The data on this type of volume is allocated alternately and evenly to each of the physical disks. You follow? So a striped volume cannot be mirrored or extended, and it is not fault tolerant. And this striping is also known as RAID 0. A mirrored volume is a fault-tolerant volume whose data is duplicated on two physical disks. All of the data on one volume is copied to other disks for storage. So if one of the disks fails, the data can still be accessed from the remaining disk. A mirrored volume cannot be extended, though. Mirroring is also known as RAID 1. A RAID 5 volume is a fault-tolerant volume whose data is striped across an array of 3 or more disks. Parity, which is a calculated value that can be used to reconstruct data after a failure, is also striped across the disk array. So if a physical disk fails, the portion of the RAID 5 volume that was on that failed disk can be recreated from the remaining data and the parity. The system volume contains the hardware-specific files needed to load the Windows, for example, NTLDR, boot.ini, and ntdetect.com. So the system volume can be, but doesn't have to be, the same as the boot volume. So the boot volume contains the Windows operating system files, and that's located in System Root and the System Root System32 folders. The boot volume can be, but doesn't have to be, the same as the system volume. Now, if you use dynamic disks on your Windows computer, you will inevitably need to manage or convert dynamic disks. So here we're going to show you how to create volumes on dynamic disks and then how to convert a dynamic disk. So here we need the help of disk management, and you can create volumes on dynamic disks all by yourself. We'll just go through a couple of steps to create some simple volumes. So you got to go to this PC, Manage, and Disk Management. So right-click the unallocated space on the dynamic disk and choose New Simple Volume. Then follow the on-screen instruction to finish the remaining process. Now, of course, depending on the type of volume you want to create, the way to create a new volume is slightly different. So let's say that you want to convert to a dynamic disk. Disk management also allows you to convert a basic disk to a dynamic disk. And again, we can wrap it up in 3 steps. You just go to this PC, Manage, Disk Management, right-click on your basic disk and choose Convert to Dynamic Disk. OK, and convert. Then you got to confirm your operation in the windows that pop up next. And then when that is done, you have successfully converted a basic disk to a dynamic disk. All right, so that wraps up dynamic disks. I know you know more than you did before. But, of course, we've got more stuff lined up for you, and it is going to be in the next video. I'll see you then.